Thank you for joining us for the first in a series of demos. This one is focused on the Gajumaru itself, the new blockchain being launched by QPQ AG in 2024. My name is Gregory Chu. I'm the CEO and founder of QPQ. I'm joined by Ulf Viger, the CTO of QPQ, Dimitar Ivanov, the Chief Science Officer, and Craig Everett from Japan, the Chief Product Officer. So, what is the Gajumaru? The Gajumaru is a new blockchain, a blockchain that actually delivers upon the promise of blockchain. It affords the ability to trust the message, not the messenger, securely at scale. To accomplish that, it is built in Erlang, the language of telecommunications and banking, robust, secure, distributed computing. We call it the Gajumaru because, like the Japanese tree, which grows in such a way that you can't distinguish the trunks from within the organism, the same idea is at work here. At the core sits a proof of work mint that secures and networks a composable set of proof of stake blockchains. That is how we can achieve near infinite scalability. We'll talk about that in another demo, but for now, we'd like to focus on the mint itself. It uses the Bitcoin next generation protocol. That means that we can operate in real-world context at 300 transactions per second with 2 to 3 seconds for confirmation of transactions. That's faster than Visa. That's faster with greater capacity than Visa. This is the beginning of a real global system that can actually work, that can deliver upon the promise, that can take us to a point where we're actually seeing different businesses, commercial opportunities evolve and emerge on blockchain that begin to transform the nature of our economy. I'm going to pass across to the rest of the team now and just introduce them briefly as I do. Ulf Viger is one of the leading lights in the blockchain, in the Erlang world. He's been an Erlanger since 1992. And for that reason was vital to making all of these pieces work. Craig Everett came on board as the Chief Product Officer. Craig is somebody who's been working in distributed computing and computing systems for a very long time, delivering real-world products and real-world solutions for customers. And Dimitar, a crypto OG who has been in this space since the beginning, developing solutions, working on cryptographic principles and consensus algorithms. And with that, I will pass over to Dimitar to initiate today's demo.
Okay, I'll share my screen. Okay, what you see here in the back is the chain explorer. It shows real time how the chain is changing. So every transaction that goes on the chain will show up here. And that's what I'm going to show you. I open my wallet. This is the amount of Gajumaru coins I have, and I'm going to send a few to Craig. This is his address, and I'm going to send 42. I can type a short message so we can see that this is the same transaction. Well, it's not his birthday today, but let's say happy birthday. Now, when I see click send here, a new block is going to get created that includes that transaction, but it's going to be really fast. So I'm sending that, and here is the transaction. Once I click it, we can see it says happy birthday and 42 Gajumarus. This is still proof of work, and how this works, I'm going to ask Ulf to explain.
Yes, so the protocol we're using is called Bitcoin NG for next generation. It was originally imagined as a way to increase the throughput of Bitcoin. So it's based on the same idea. In Bitcoin, miners compete to solve a puzzle, calibrated to take about 10 minutes to solve. The miner that solves the puzzle gets to produce one block on the chain. Now, this gives roughly 3 to 5 transactions per second throughput. and up to 10 minutes response time if the system isn't congested, which it often is. So, and then it can take a lot longer. Also, it gives very high transaction cost for that reason, because if you want to get included faster, you have to raise the fee and bribe the miners. In Bitcoin NG, the difference is the miner that solves a puzzle, and for us it's calibrated to take about 3 minutes to solve, becomes the leader and can produce blocks until another miner comes up with a solution for a puzzle. And these blocks are called microblocks and are packed with transactions and come roughly 2 to 3 seconds apart, or immediately if the chain is idle and a transaction pops up. This gives us very high throughput, up to 300 transactions per second, and response times of up to 2-3 seconds normally before your transaction is on chain. Now, what Dimitar demonstrated was a spend transaction, which is the cheapest form of transaction. We also have smart contracts like Ethereum does, but unlike Ethereum, we have a smart contract language that is designed by some world-class programming language designers. It's very robust. It's designed partly specifically to fix most of the known security flaws in the Solidity programming language. It has a very efficient virtual machine, allowing us to also execute smart contracts very efficiently on chain. So with that, over to Craig.
Thanks, Ulf. So my perspective on this is both on the technical side, working for development, but also on the product side, having tried to build things on blockchain for real for several years, and having been foiled by the limitations of blockchain consistently. It's super, super annoying. What we see in Ethereum and Bitcoin is proof of concept systems that they prove their point. The Nakamoto paper about distributed consensus and how that could be used in a proof of work sense to create and protect create a currency that's digital in nature and is not debasable by any single authority. That's great. Bitcoin proves that can work, but it only barely proves that it can work. It's not it's not robust enough to be the basis for a product series. Ethereum, same problem in terms of throughput, but that project did prove that you could use the state of a blockchain as the backend for an ongoing state machine. The execution context of programs could be the state on that blockchain and so on. Excellent. However, like many proofs of concept, there's a lot of gaps there. There's huge pitfalls. There's pitfalls in the EVM that are so bad that you can't prove anything about a contract on Ethereum. Heavily audited contracts always have security flaws in them. It's crazy. I'm glad that work happened. It's fantastic it happened, but that needed to get cleaned up before you could build anything real on top of it. So from a product perspective, I'm really excited about this. This is the direction that blockchain should have gone a decade ago, but we got distracted by the hodl bros and the big number go up, crazy speculation stuff, where everybody was looking for a get rich quick kind of windfall profit thing instead of looking at business models. And what is a business model? How do you make money? How do you provide a value? They're just trying to, catch money while it's falling out of the sky, so to speak, which is not sustainable at all. In that vein, QPQ's perspective, and the reason I'm here with QPQ is that we've got a bunch of different ideas of businesses that we want to build on a blockchain. To do that, though, we need a blockchain that works, and there aren't any. So from QPQ's perspective, it would have been great if there was already an awesome blockchain out there, but there aren't any. So we had to solve that problem first, and we wish we could have avoided it because it was really, really hard. However, that work being done, we can move on and start productizing things, building products on top of this. This is the direction that we should have gone 10 years ago. Didn't happen that way. Now we're finally making up for kind of lost time in that sense. And QPQ, yes, is operating a blockchain. The business models, though, are discrete business models. The blockchain itself is not the business model. There are, of course, upsides to being the operator of a blockchain because you're first mover and so on. But windfall profits, as I said before, they are not business models. Anyway, this is where we're supposed to be. Thank goodness. Very happy about that. The low latency, this idea, the design principle of Bitcoin NG, where you have proof of work, the proof of the work being separated from the work of ledger updates and inclusion. That's a very clean, very natural separation of concerns. It should have been obvious years ago. Nobody picked up on that. So whatever, we are. This is where we're supposed to be. That low latency lets us do things like retail level transactions on chain, which is awesome. So very excited about this. If Greg's got something to say on the way out, we're just super happy that this is finally happening. And you're muted.
Thank you to everybody. And again, I'm muted, so back on stage. Yeah, look, I've been working at this for 22 years now. The idea of how to build a new economic system that everybody can participate in, everybody can join into, and how we can begin to use that as a tool to create an economy in which we can all participate. These have all been things I've been working at for a very long time. I never thought I'd have to actually build the blockchain. You know, when I started this again in 2017, it was because I'd seen the emergence of directed acyclic graphs and thought they could actually achieve some of the, or solve some of the problems that I saw in the existing systems. Actually, they didn't really do that. And by and large, they ended up becoming EVM-driven systems, and they had all of the same flaws and problems that come with Solidity and EVMs. So my constant bugbear has been that this is an industry replete with proof of concepts that really haven't evolved to become minimum viable products, never mind fully commercialized products. This is why we have a constant discussion about how we get the other 99% of the world to start using cryptographic instruments, currencies, and blockchain. It's going to stay 99% until something like the Gajumaru comes along that says, hey, you know what, we're actually going to give you the scalability and the throughputs and the security and the certainty that is necessary in order to be able to do the basic but incredible thing that blockchains allow us to do, which is to trust the message, not the messenger, securely at scale. I have never, nobody on this demo has ever been party to the number go up game. I've never released a white paper in all the years I've been doing this to talk about how somebody can give me money so that I can build something that may or may not work. And the object, as everybody knows in the background, is just to have the number go up and some poor people to be left holding the bag. I've taken that hard road because I think the integrity of this is important. I think this technology offers us an opportunity to change everything. And we need to do it the right way for the right reasons in the right way. And that's exactly what we've done here. It was just not possible to achieve all the things I want to be able to do with blockchains until we had a functioning blockchain. The amount of heavy lifting you need to be able to do that is phenomenal. And I've been extraordinarily lucky to have met these gentlemen and managed to bring them back together with what we're doing in QPQ and actually deliver a blockchain that accomplishes all of these things. So this is the first of a number of demos. The next one will be looking at how we can enable market operations. We'd love to talk to people who want to build something on blockchain, but maybe have found that the existing services don't offer the things that they need. Whether that's using the Mint or an associate proof of work chain, or proof of stake chain. Get in touch, and thank you for listening. Bye-bye.